this is Mr. Coates, and this is Apes Lecture number 38. We're going to talk about outdoor air pollution today, specifically smog. This is a aerial photograph of Asia, and this areas here, these are all areas of smog, and this is known as the Asian brown cloud. And because Asia has such a poor problem with air pollution control right now, they put out a lot of smog. And there's a huge problem in Asia because of this, and it's mostly due to the fact that they're burning lots of coal without any kind of air pollution measures. They have lots of automobiles, lots of vehicles, there's lots of outside burning, and none of these countries really have any air quality standards like the United States does. So we get these large areas of smog, and this is known as the Asian brown cloud. And you can even see it here. This is a picture of an airplane flying past the Himalaya mountains. You see how brown it is down here, and that's all due to the pollution that's put out by those Asian countries. So what is smog? Smog is a mixture of all kinds of different pollutants, particulates, water vapor. They can be primary pollutants, they can be secondary pollutants. And then there are two types of smog. You can have photochemical smog or you can have industrial smog. So let's look at both types here. First of all, photochemical smog, also known as brown smog. This smog is created when those secondary and primary pollutants start interacting with sunlight. And you must have sunlight in order to have these reactions. So when you have nitrogen oxides and VOCs, or volatile organic compounds, react under UV light from the sun, they start creating this brown cloud. And so you get things like NOx's, those are NO2s, NO3s, volatile organic compounds react together to form ozone at the tropospheric level, which is bad, as we said before, as well as aldehydes and paracetyl nitrates, or PANs, and these are also all bad pollutants that you don't want. And so you get this brown layer, and it usually peaks about mid-afternoon in large cities that have smog problems. And the important thing here is a lot of these VOCs and this NOx gives you this ozone part here. So once the sun goes down, this brown smog goes away at night. So what are some of the effects of this photochemical smog? Obviously, they can damage your respiratory tract, and damage crops and trees from the ozone. I mentioned ozone is a very good oxidizer, and whenever ozone encounters any kind of organic matter, it starts to break down that organic matter. Some of the top smog cities in the United States include Los Angeles, Denver, Salt Lake City, and this is mostly due to some of their geography. We'll talk about that in a little bit, but they have warm, dry, sunny climates, and so this provides the opportune time for the sun to react with these pollutants. Now, I also mentioned gray smog. This is also known as industrial smog. Now, industrial smog comes from the burning of sulfur-containing compounds, fossil fuels mostly, coal, and also the combination of soot particles, which gives the atmosphere its gray looking. You can also have water vapor interact with the sulfur dioxide to form sulfuric acid, and this can cause burning of the lungs and the eyes and any other kind of thin tissues in the body. It is usually rare for you to find this kind of smog in the developing world due to our pollution controls. However, China, India, and some of the Slavic countries still have a huge problem with gray smog, and this is mostly to their increase that you see in this graph here of burning coal. In the United States, our increase has been very minimal when it comes to burning coal over the last 60-some years. However, over the last 12 to 15 years here in China, the amount has gone up exponentially. And they're having a huge problem keeping their pollution, as you can see in this picture down here, under control. This could be any day in China. So what are some factors that contribute to gray smog? Sea salt spray can do that because you add all kinds of chemicals to the atmosphere that can interact with those particulates and form this gray smog. Buildings, hills, mountains often block air movement, and they can prevent the movement of gray smog from moving out of the area. However, in areas where you do have good wind flow, typically you don't have smog building up, and that's one of the things that we have here in Florida, is that because of our wind patterns and the lack of mountainous areas and things like that to trap the atmosphere, our atmosphere moves rather easily here in Florida, so we don't have huge problems with smog buildup here. We have to realize we do produce these pollutants, however, and so what happens is what we call this grasshopper effect. We produce these pollutants, but they don't affect us, and they travel somewhere else, and they will affect those other places. And one of the places that they're really starting to affect is the poles. If you look at the world's wind currents, the wind currents overall tend to push most of the atmosphere eventually towards the poles. And the poles can be a huge collection spot for a lot of these air pollutants. And so we're getting a lot of air pollution in areas where people don't even live from all of these areas that the wind blows the pollutants from. Well, I mentioned cities like LA, Denver, and Salt Lake City have a huge problem with air pollution, and this is because of an atmospheric phenomenon called a thermal inversion. And what happens in a thermal inversion is that cooler air that is found usually in the valleys or coming off the ocean here gets trapped by a warm air layer. And this inversion layer that's in between doesn't allow the two to mix back and forth. What happens is that all the pollutants from the city get trapped because of that inversion layer and can't get out, especially if you're in a valley like Salt Lake City or Denver. In the case of LA, you have a cool sea breeze that's coming in all the time, and you have descending warm air that comes in because of the sun's intensity at that latitude. And then you have the Sierra Nevada mountains that are out here, and the Sierra Nevadas stop the actual wind from blowing the pollution away, and it just gets stuck there over the city of LA. And this is why LA tends to have a huge pollution problem compared to other cities on the West Coast. San Francisco typically doesn't have a huge air pollution problem because they aren't trapped with these mountains on the eastern side of the city, whereas LA is kind of like a big bowl with the Pacific Ocean on one side and the mountains all around the other sides. Now, one of the questions out there is CO2 a pollutant? There's a huge fight now in the world about CO2. And is it contributing to climate change? And should we reduce the amount we're putting out? And things. There's been all kinds of conventions, treaties, and meetings between nationalities to determine what everybody on the planet is going to do about CO2. And unfortunately, it's not an easy question to answer because different countries put out different amounts of CO2. We have different types of industry and infrastructure and the ability to control pollution, and then some of those countries don't have the ability to control pollution, so it gets into this huge argument about who's going to do what and how much you're going to reduce your CO2 by. But one of the early arguments was whether CO2 is actually a pollutant, because you and I, as we sit here watching this and recording this, we're breathing out CO2. So how can CO2 be a pollutant when we're breathing it out? And then trees take it in and use it. So how can it be a pollutant? Well, it's one of those things where too much of a good thing can become a bad thing. If you get too much concentration of CO2 in the atmosphere, then it can actually increase climate change, and also it can actually diffuse into the ocean in higher levels and create ocean acidification. And so we'll talk about that when we get into some water pollution and also get into climate change issues. But when we get into climate change, we'll talk about the ever-increasing concentrations of CO2 in our atmosphere and the ramifications of that. In this class, we're going to consider CO2 a pollutant. The excess CO2 we're putting out is polluting our atmosphere. I mentioned the grasshopper effect a minute ago, and this is haze, and you can see this area right here. It's all hazy and gross. But that is in the Arctic. Once again, nobody lives up there. There's no factories. There's no major cities in the Arctic, and it's just haze that collects from other areas. The atmosphere brings that pollution. The problem with air pollution is a worldwide problem. It's not just a problem in developing countries, because if developing countries produce the pollution, it's going to eventually move to where the developed countries are. So this is a worldwide problem because of the grasshopper effect, and everybody in the planet needs to get on board with controlling air pollution and dealing with it. Well, I hope that gave you some information on the outdoor air pollutants. The next lecture will be on indoor air pollutants.